Okay, good morning, everyone.
Good morning.
Welcome, Dr. Principal Jignesh Vagasya sir, as well as Dr. Nikunj Patel sir. Behalf of Sri Swami Atmanand Saraswati Institute of Technology, I, Kausik Dhola, from Electrical Engineering Department, welcome you all are in this 5 days online short-term training program on new scope of research in electrical engineering, organized by Department of Electrical Engineering, Sri Swami Atmanand Saraswati Institute of Technology, Surat, in association with Guj Coast. The resource person of this online STTP are Dr. Nikunj R Patel, HOD, Electrical Engineering Department from SASIT, Dr. Mohan Kohli, Professor from University of Edgar, Norway, Dr. GJ Jamnani, Associate Professor, PDPU, Dr. Ritesh Patel, Professor and Head from GSET, Dr. Prasanta Kundu, Associate Professor from SVNIT, Dr. Varsha Shah, Professor from SVNIT, Dr. Sabaraj Arya, Associate Professor from SVNIT, Dr. Pritam Gujrati, Certified Energy Auditor, University of Technology and Applied Science, Rizwan, Oman. For this STTP, more than 90 registrations, around 50 faculty members, 40 students and research scholars. I thank to coordinator Professor Kunal Chaudhary, convener of this event Dr. Nikunj R Patel, and our beloved principal Dr. Jignesh Vagasya for giving necessary support to organize this event. I also thank to our management STBS Trust. Last but not least, once again I thank to all participant and resource person for this program. I hope you all are enjoy and utilize this 5 days online program. Thank you. Okay, now let us start our first session. Before we start, let me introduce our today's expert, Dr. Nikunj R Patel, HOD from Electrical Department, SASIT. Let me introduce. Currently, Dr. Nikunj Patel is working as an head in Electrical Engineering Department, SASIT. He has completed his PhD from SVNIT, Master from Nirma University. He possessed 13 years experience of academic as well as industrial. He has published around 10 research papers at various national and international journals and conferences. And he has published 3 books at various topics of electrical engineering. Now, I would like to hand over this session Dr. Nikunj R. Patel. Thank you.
Thank you, Professor Kausik sir, and really thankful from the heart of Dr. Jignesh Vagasya sir. And I am also thankful to the management. So let I start my session without wasting the time. Thank you one and all. Okay, I am audible. Hello. Professor Kaushik, I am audible and visible.
Yes, sir. Yes, sir. Go through it.
Okay. So today I am going to discuss on role of electric motors in advancement of electric vehicle. Actually, as we know, the electrical vehicle is a future. And if we think for the electrical vehicle, then as the electric motor is a crucial part of electrical vehicle. So today I am going to discuss on the electrical motors and importance of that electrical motors, which type of motors are applicable, which type of changes are possible for the betterment of the electrical vehicle. And I have also covered the big literature reviews about some specific motors, and I hope so it will be really helpful to you. So let I start. The first, as I know, the number of participants are divided into the two groups. One are the faculty members, and second are the some are the students. It's maybe they are going for the research. So the quality of good engineers and researchers is if they asking a questions themselves like a what, why, and how. Ultimately, due to the what, why, and how, the invention, innovation, discovery, and creativity comes into the pictures. And because of that, ultimately research is possible. So the today's discussion topics are history and current scenario. Of course, we have to take a small review about the electrical vehicle. Exactly what is the electrical vehicle and what is the need of that electrical vehicle. The basic classification of EV, then construction of the EV, then role of electric motor in electrical vehicles, then classification of electric motor for electrical vehicle application. Then we discuss on the comparison of different electric machines. We will also discuss on the comparison of axial and radial field machine. This is the really importance. These are the two techniques based on that we are able to design the machine. Different designs of permanent magnet BLDC machine and SRM machine. As we know that at now the many motor manufacturing, it means the electrical vehicle manufacturing companies are started to deal with the permanent magnet machines and the SRM machines. Okay, so we will discuss on this particular topic. Then we will comprise that, and we will focusing on this particular portion. First, why think for the electrical vehicle? So if we know that electrical vehicle, it's a option of that particular internal combustions vehicles, which we are used and we are too much familiar, and the mature technology is available in field of the transportation. But the problem is they all are work on the petrol, diesel, CNG, hydrogens. It may be the some vehicles, okay, right? And because of that, the issues that comes into the pictures. The issues are, of course, the greenhouse gases because of the PM particular particles, then CO2s, then methane gas, then nitrogen oxide, then sulfur dioxide, and due to these gases, many problems occurs in the society. So here I have listed this particular are extremely small and in range in micrometers, as we know, and therefore they cannot be filtered by the human thoughts. And because of that, what's happened, the body and heart, lungs, and brains are affected because of this, and it is really dangerous for the society. So we have to think for electrical vehicle. There is a no option. If we focus on statistic, then we can easily find out that greenhouse is the issues. The CO2, it is responsible for that, and this CO2 is emitted in the which basically field, then we can easily identify that the maximum 43.48 percentage carbon dioxide it pollutions is occur due to the road transportations as per the statistic data. So of course, if we reduce or if we think for this particular transportations portion, then we are able to control the greenhouse effect. And the solution is electrical vehicle. Now, if we go a little bit further with the more statistic, that the global pollutions with current rate may be increased from 6 billion to 10 billion in 2015, because we have to think for the futures. Of course, so the day by day transportation is goes up. And because of that, vehicle is used maybe increase 700 millions in 2000 and 2.5 billions in 2050. So it is a very big issue. And if all the vehicles are ICEV, internal combustion based, then what's happened? Just think for that. So, according to the ARB reports, 2011, this is the very oldest report. But if we go for the 2 days, of course, the numbers are increased. The 9,000 people die per year due to only the fine particles matters in California only. If we think for the India, then definitely the numbers are increased because our populations and pollutions are little bit growing more. So, what is the solutions? So one of the promising solution is sustainable transportation. So there are the three possibilities: low or zero emission vehicles we have to introduce. It means the battery electrical vehicle, because internal combustion has technology is already matures. Now we cannot reduce the emissions is possible today. Now, promotion of public transport, but it is little bit difficult because the all peoples are believing in that personal transportation. Then renewable energy sources, less dependent on the fossil fuel. But here also we have some limitations about the technologies as well as the renewable sources. So we are not all are shifted that particular renewable energy sources. So one and final conclusion is zero emission vehicle we have to introduce. And if we compare the different type of vehicle for the better understanding, then here you can easily identify that the BEV, battery electric vehicle, then fuel cell electric vehicle, and internal combustion engine. If we consider the three vehicles and we compare, then we can easily identify that the efficiency level of BEV is 72% nearest to. The fuel cell electric vehicle is 40 percentage, and here the 60 percentage. Okay, so of course the battery electrical vehicles efficiency is comparatively more, so definitely it's pollute less. But the question is about the electricity, because here we input source is gasoline, but here the input source is electricity. And if we use the conventional source, then also the problems occurs that when we produce the electricity, at that time the some losses are occur. So the main challenges is how to produce the electricity. So huge electricities are required, of course, if all IC engine converted to the battery electrical vehicles. Now, if we increase the power generation, then the ways are thermal power plant, gas-based power plant, diesel power plant, hydro power plants, nuclear power plants. But these are the technologies which we are already used with a very high scale. But the problem in thermal gas and diesels are same. They all are produce the gases which are responsible for the greenhouse effect. Of course, hydro and nuclear are the better pollution free energy, but hydro has some limitations about the environments. And similarly, in a nuclear power plant, also there's limitations because of its difficult and very dangerous for handling. So the option is wind and solar. But as per the Indian environment, then we can find out that the solar is perfect because in India, the throughout the years, the sunlight is available with the maximum kilowatt hours per meters. If we compare with the same input for the battery electrical vehicle and IC vehicle, okay, right? So here we can easily identify that the crude oil and crude oil is the input. And if we go through it, then by using of that crude oil, if we generate the powers and then we utilize for the battery electrical vehicle, then also the efficiency is 80%. Okay, if we are not shifted to the wind or solar or other non-polluted electricity generating plants. And in the conventional manner, it gives us the 30%. So if we use the same structures of the generation and if we introduce that particular battery electrical vehicle, then only we get the some benefits. Okay, but this percentage ratio, it means here the 30 and 80, it is not too much bigger. So if you want to increase this, then definitely we have to replace this crude oil or the conventional sources of production of the electricity in a non-conventional sources. So the conclusion, it is of course the solar, and our government has also adopted these things, that the no EV without the solar acceptance in our country, especially for India. Okay, and the sunlight is nicely available around the Indian land. So the question is, what is electric vehicle? So electric vehicle is basically divided into the this four parts: battery, then the controllers, then motors, and we can say that the transmission. So battery, it is a basic source of the electrical energy. That energy is transferred to the motors with the controller with the proper manners. But the question is, the motor mechanical power is how to transmit to the wheel. And there are the lots of possibilities, lots of the manners by we can transfer this power to here, and for that purpose we have to use the transmission. Till date, the 98% vehicles are using these transmission systems, but nowadays 2% companies are shifted to the in-wheel technology, where this motor is directly fitted inside of this wheel. Then what's happened, the transmission scheme is removed. So what is the beauty of this, that this particular transmission losses we are possible to remove. So now question is, what is electrical vehicles? So of course this is the pictures of current electrical vehicles, and this is in our mind, but we somewhere forget it is a very simple technology. If we compare with the electrical toy, the block diagram and everything is remain same. Here also the battery, here also the motors, and here's also we can say that the transmission scheme. Okay, right? And here we have to apply the charging scheme for charge this rechargeable battery source. The same things in particular electrical vehicle. Okay, the charging battery and electric motors. And for third purpose, so what is the difference between these two? The difference between these two is the particular small toy is not able to carry the load and weight, not designed for the high speed. It has no mileage. And if we go for the big size, then the problem is economy. Okay, right? It means the price of that particular EV. So if we deal with this particular four parts, then we are easily convert the toys into that particular electrical vehicle. So of course, the challenges are there for designing and implementation of the electrical vehicle. So which are the challenges? The first one is a huge electric power, battery charging time, battery life, high initial cost, grid connectivities, then limited range, then high speed with the high torque, of course, then consumer acceptance, because we know that today's the many models are available in market, but people are not accept just like a conventional vehicle. Same the government policies. Of course, there are little bit lagging, especially in our countries, that government policies are not clearly designed. Due to that also, that particular responsible for that electrical motor. So we will think on electrical motors. And some are the students. Some are the students in this particular STTP program. So I just give you the some information. If why should learn electric vehicle, okay, and how much importance of the electrical engineering. So look at here that if the all gasoline vehicles are converted into the electrical vehicle in futures, it's maybe a 2025, 28 or 30. Okay, then what's happened? All petrol pumps it's converted into the charging station. If on road the number of electrical vehicles are increase and increase, all electrical vehicles comes to the garage. Conventional garage are replaced with the electrical garages. Now huge amount of powers are required, so all refineries are converted into the power plant. Okay, it's maybe the people are diverted to the solar solution. So nowadays, aware about the solar farm and everything. Now existing grid is not sufficient. Okay, of course. So the transmission is required to upgrade. So of course, electrical vehicle is the futures of nation, and it will become the big opportunities of electrical engineering. And main and important parts of electrical vehicle is a electric motor, of course. So before that, the questions rises in our mind that what is the history of that electrical vehicle? It's recently introduced? No. It is invented in 1838. A number of companies in USA and UK start to just think for the electrical vehicle. And in last decades of the 19th century up to the, but then after what's happened, it almost not thinking on that particular, almost one is in 1930. And then afters, when the people are aware about the environmental causes, environmental problem, then once again people have start to think for the electrical vehicles. Okay, and once again the people are try to introduce the more and more electrical vehicles. And but till that are not a big acceptance of electrical vehicle in society. If we think for the electrical vehicle, different types of electrical vehicle, then basically it's divided into the three parts: battery electrical vehicle, hybrid electrical vehicle, and fuel cell electrical vehicle. Okay. In battery electrical vehicle, purely batteries we have used for the primary sources. In hybrid electrical vehicles, we use that particular battery as well as the other source of fuel we use in a hybrid manners. And in fuel cell, where we use that a fuel cell for induce the electricity, and then after we use that for a propeller the motor. If we classified that, of course, the ICEV, why we say that the ICEV, the question in your mind, because in existing IC engine vehicle is also the electrical vehicle, but it's in a micro manner. Why? Because we use a battery for starting purpose of that particular vehicle. Every auto start vehicles are use a battery, and the particular dynamos and everything for the charging process. Okay, right? So this is the micro scale electrical vehicle. So we not using that ICE, purely internal combustion engine, where we are not using vehicle means where we are not using the battery at little bit. Okay, but nowadays we are using the ICE. Then it is forwarded to the people are just thinking for the hybrid electrical vehicle. It means the IC engine or other technologies are there, but with this the electrical technologies, the particular contribution of the electrical is a little bit more. And this is advanced electrical vehicles, where the battery electrical vehicle or a fuel cell electrical vehicle. So if we compare these three basic technology of battery, hybrid, and fuel cell electrical vehicle, then we can, I am just interested here in the propulsion systems. We can easily find out that in every scheme, the one thing is common, is a electric motor drives. Okay. And the today's topic is also focusing on that. The contributions of electric motor in a electric vehicle. So before that, we just take the block diagram. It may be the some audience are not aware about that particular electrical vehicle scheme. If we think for the battery electrical vehicle, then what's happening in a battery electrical through the grid or through the source, we just charge the battery. Then after, the power converters is required to manage the power level for the motors. Okay, and motors through the transmission gear, it's run that particular way. Okay, this is the battery electric vehicle. Similarly, the in fuel cell electrical vehicle, the scheme is remain same, but here's the hydrogen tanks. It's used as a hydrogen is a primary fuel, and from these fuels we just produce that particular electricity. We charge the battery bank, and then we transmit the produce the power through the motor. Okay, so FCEV. But in both of the parts, motor is a crucial component. So whatever the efficiency is delivered by the motor is considered as a direct efficiency of that particular EV. Similarly, the hybrid electrical vehicle. Hybrid, it means what? The conventional IC engine we used, and parallelly we also use the battery. So these are the hybrid electrical vehicle. There are the three possibilities of the scheme: series, parallel, and series and parallel. Here I have just put up the diagram for the block diagram for the series and parallel. Okay, I'm not just discussing more about it because of this is only for the understanding. We have to focusing on motor parts. Now, electric motors, battery electrical vehicles. Of course, the battery electrical motor is a more important parts. The question is, which type of qualities are required? The conventional batteries are possible to replaced in IC engine. We can just use that conventional motor. Is it possible? And which type of qualities are required, which type of characteristics are required for the electrical vehicle. So of course, small in size, motor should be small in size, and axial length should be small if we want to fit in a in wheel ke under. Then the efficiency is too little bit high, of course. Then the power density must be high, then torque must be high, because when we start the motors at that time the torque ratio is comparatively high. Now very wide speed range is required, because our vehicle is not run on constant speed, it's continuously vary the speed. Now high efficiency is required, of course the all gains are planned because of that the efficiency level. Then the torque response, the fast torque response. Of course, it is a basic need of electrical or any type of the vehicles. And the high reliability, because the vehicle it is a use in different environment. So it should be reliable for the and compatible for the all environments, and robust structures. And of course, the cost must be affordable. Otherwise, the thing is not accept. So the question is, which type of motors are available? So there are the two types of motors, electric motors are available: commutators and non-commutator-less. In commutators, the series shunt, field excited, and the permanent magnet excited machines are there. And the many people are aware about this particular machines. Then we have to think for the commutator-less motor. The induction motor, where the wound rotors and squirrel cage; synchronous motor, where the wound rotors, permanent magnet rotors, and reluctance motors also possible in synchronous machine. Then purely speed reluctance motors, it is also say as a stepper motor. Stepper motor without the permanent magnet. Okay, right? So there are the two possibilities, that the stepper motor with permanent magnet, stepper motor without permanent magnet. If it is without permanent magnet, it's considered as a switch reluctance motor, because switch reluctance motor is also work in steps. And permanent magnet machines, if we introduce, then it is also works in step. We will think later on. And there are the main two technologies comes into the pictures: axial flux and radial flux. It is the most important aspects. And this is really important for the electrical vehicle. Just we take the small block diagram and constructional view of the induction machine, you can easily find out here the two parts, the stators and rotors. Okay, right? This is the induction machine, which we all are aware about it. Then asynchronous motors, where we use our AC as well as the DC excitations. Okay, AC supply and DC excitation for rotate this. Okay, this is something figures, and it is something working in this manner. I think so all people are aware about it. Now the DC motor. Okay. In DC motors, that particular permanent magnet are situated at here, or it may be we have to provide the excitations and the EMF is induced according to the Lenz's law. Now the our journey is starting from here. If this permanent magnet is, if this particular thing is replaced with that permanent magnet, then this is a permanent magnet DC motor. Okay, right? And this is widely used in a practice. But if we use this permanent magnet inside of this as a rotor, then what's happened? Permanent magnet is used as a rotor, then this is the permanent magnet brushless DC motors. Are you agree with me? And this is not a conventional one. Here we have to provide the excitation in such a manner that it's rotate in a clockwise and anti-clockwise as per the excitations. And this motor is working in a phase. Now here if we compare the different type of motors which we have discussed in this particular classifications, the DC motor, induction motor, permanent magnet, SR and PM, then we can easily identify, and we are just focusing on this total. You can easily identify the permanent magnet is most suitable for electrical vehicle. This all comparisons is designed based on electrical motor. So the permanent magnet brushless DC machine is most suitable. And induction motor is a mature technology. You know that in industry, 90% motors are used induction motors. Okay, right? But the question in induction motor is the induction motor's power density is too much low. So wherever we use an induction motor, we have to use the gear drive. We cannot put up the induction motor or use the induction motor as a in-wheel. Okay, so for that purpose, there is a limitations of the induction motor, and of course the efficiency level is also little bit low. But if we go for the permanent magnet, the efficiency and everything is good. Okay, and look at here the SRM motor, switch reluctance motor, it is also the parallelly with the induction motor, and here has the power density is good. Okay, so here we can easily find out that the permanent magnet, brushless DC motor and SR motor is fit for that particular electrical motor. Now we go for that characteristic. Okay, which character? So here we can easily identify the characteristic of EV, electrical vehicle. It means the electrical vehicle need this type of characteristics, torque speed characteristic. Okay, right? Where at a starting the torque must be a constant, and then afterwards the power must be a constant. The gradually torque is decreased with respect to the speed, but the power is must be a constant. Are you agree? And now we compare this characteristic with the different type of machines. This is the DC series machine. So you can easily find out that the DC series machine, the characteristic is not perfectly matched. Okay, right? Now if we go for the DC shunt motor, then also the same things, the characteristic is not matched because here the constantly the torque is speed is approximately constant with respect to the torque. Then synchronous machine, it is also the not match with the EV. We can easily identify, no need of the any type of the explanation. But if we go similarly induction machines, okay, the induction machine characteristic is not matched, but maximum a number of motor manufacturers are use the induction motor. Why? Because it is a mature technology, and by using of the frequency control or any other control, we are able to just create the characteristic just like this. And here also we have to use the gear mechanism as well as that particular transmission scheme. Now, if we think for the SRM, switch reluctance motors, okay, so look at here, the characteristic is nearest to matched. Okay, so of course, through the characteristic, we can easily say that the SRM, switch reluctance motor characteristic, is matched with EV. So this is a more suitable with the EV. And if we go for the DC motor, the DC motor characteristic is also the nearest to same, but at the starting torque, we have to maintain. So for that purpose, if we introduce the permanent magnet, then the DC series motor also we have to just shift it at here. Okay, right? And in nowadays in traction, the DC series motor is already used. So if we just focusing on the current scenario of the different company that they are using which type of machine. So look at here in a Skoda, the permanent magnet machine, synchronous machine is used. Then Tesla SRM is used. Then Ford permanent magnet synchronous machine is used. And here you can easily find out that different machines are used in different electrical vehicles. It's based on that EV manufacturer. Actually, what's happened? If we think for the Tesla, then Tesla is really rigid about the induction machine. Okay, so they are believing to advancement in the induction motor first, right? They are not shifted to the permanent magnet machines because the permanent magnet, it is also the one big issue which we will discuss afterward, and I also put up the result. Okay, so the SRM is permanent magnet free machine, so Tesla is shifted to the induction machine to the SRM, right? But the other machines have adopted the current technology, and basically many manufacturers are use the permanent magnet machines. Okay, right? So you can easily identify the different machines are used in the electrical vehicle nowadays. But here you can identify BLDC, AC, SRM, and PMS. These are the main machines which used. So of course, just we have discussed by using of variable frequency drive, we can use the induction motors. But there are the limitations which we already discussed about the in-wheel and power density. So these two machines are really good and really fit for the induction for the electric vehicle, the permanent magnet brushless DC machine and switch reluctance machine. Now, if we want to fit this particular machine, then there are the three possibilities. First one is the in-wheel. It means this particular machine is directly fitted in in-wheel. Here you can easily find out. Okay, right? The motor is fitted inside of the wheel. Okay, so no transmission is required. Right? Second scheme is motor on shaft. If we put up a motor on shaft like this, look at here, we have put up a motor. Okay, right? And this propeller, the both of the wheel. Okay, right? Where the external gear mechanism is not required, this particular motor is just powered this particular two wheel. And third is the conventional one, motor with gear or belt. We have to be free to put up the motor at anywhere. Okay, right? And by using of the pulley or by using of the gear drives, we just transmit the power to the wheel. Okay, right? So we just focusing on, now people are focusing on in-wheel technology, because if we use the in-wheel technology, the transmission losses is almost zero. Okay, and we have find out the maximum losses occur during this transmission. Okay, so we can conclude up to the today's up to the this whatever we have discussed, the permanent magnet machines and SRM is a fit for the electrical vehicle and especially for in-wheel technology. Okay, now we go further. Detailed study of SRM and PMAC. So first we should clearly understand what is SRM and what is a permanent magnet machine. Or just we think for the stepper motor. This is known as a stepper motor, as I have told previously, right? So SRM, it means the switch reluctance motor. It means it's follow the low reluctance path. Are you agree with me? So look at here, how many poles available at the status 1, 2, 3, 4, and 6, and 2 at a rotor. So this is a 6 by 2 structures. And how many phases we have provided it here? So you can easily find out that the three phases are provided it here. So if we excite the phase in such a manner that our rotor is follow the roll reluctance path and it's rotate. Okay, right? So this is the basic working principle of switch reluctance motor. Right now, in the same motors, if we replace this particular rotor with a permanent magnet, then what's happening? For the better understandings, here we can easily identify. These are the phases. The stator is a phase. How many phases we have put up at here? The two phases and four poles we have excited. And this is the rotor. So whenever we excited that particular phase, then what's happened? Our rotor is shifted. Okay, right? Here in a first condition, this is the excited. Now whenever we excite the both of the force in such a manner that this is set on the in between. Okay, so that step, it is known as a step angle. Are you agree with me? This is a step angle, and this is also the big issue for the electrical vehicle, because whenever the step angle is big, then what's happened? The jerking comes into the picture, so the torque ripple comes into the pictures. So of course, this types of motor is good for the electrical vehicle, but the problem is regarding the jerk. Are you agree with me? So how to reduce that? The people are working on that. Okay, and I will also discuss on that particular issues. Look at here, the complete structures. These are the permanent magnet. Okay, we excite the one by one phases, and according to that, the rotor will rotate. Okay, in this both of the technology, the problem is here we require the controller for rotate this, because this is a commutator. So here we require the controller, and controller is designed based on the position sensor. Okay, so of course the control mechanism is little bit difficult compared to the conventional induction and DC machine. Okay, so this is the biggest limitations we can say for this particular machine. But nowadays, as the power electronics research goes on, this is not a limitation. The number of technologies and microprocessors and controllers are available for the fast operation. Now we are clear about the PM stepper motors, and in stepper motor SRM and PMBLDC machine. Now look at here, there are the two type of flux distribution. As we know that in a conventional things, we just think like this is the flux distribution. Whenever my rotor is set in such a manner that my flux is distributed in this manner, just like an induction machine. Okay, right? Because only this phase is excited. This B and A dash is not excited. Only C phase is excited. So my flux is distributed in this manner, half at here and half at here. Okay, right? Okay, so this is the radial technology, radial field distribution. But if the same models we have shifted like this, it means this particular pole is managed like this, then what's happened? My flux is distributed in this. It means here you can easily find out that that particular magnetic field, it is a perpendicular of shaft. Here the shaft is coming outer side. Here the shaft is coming outer side. Okay, right? So that particular magnetic field is perpendicular, and here you can easily find out that the magnetic field, that particular magnetic field is set up in a parallel with the shaft. Are you agree with me? So the main difference in these two is here the flux length is more. Flux has to pass the setup in the length of that particular flux is more length, and here the flux length is less, of course. So the reluctance offered in this area is more compared to the axial field distribution. Okay, so the thing is proved that if we design the radial flux and axial field with the same dimension and same contact area of the stator and rotors, then it's give the 178 percentage more power. Okay, right? It means of course the efficiency is more, power transmission is more. Okay, so of course the people are diverted from the radial to axial field technology. This is the conventional one technology. Once again, I go for the last slide. This is the conventional radial field technology, and this is the axial field technology. And based on this, we can say that this is give the 178 percentage. Now, how can we just blindly accept these things? So for that purpose, I will just produce the some result also. Look at here, the same structures we can find out. Now here we compare these two technology, axial and radial, by this equation. This is the mathematical modeling of that particular radial field machine and particular axial field machine. Okay, right? And if we compare these two particular mathematical modeling, and if we put up the same value, then what's happened? Look at here. Compared to the radial field machine, axial field machine, torque arrow characteristic is good. Arrow, it means that outer radius. Okay, right? It will also, we can say that the diameters of that particular model. Okay, so look at here. So in the torque is more in case of the axial field compared to the radial field. Now similarly, here we can easily find out the arrow versus torque, okay, with respect to the arrow versus ri. What you mean by that, the arrow versus ri? It means the inner and outer diameter. Once again, I go for the previous slide. Look at here. The inner and outer diameter. It means on this figure, we can easily find out if we starting from this shaft, then shaft to that particular positions and here to the particular positions, whatever the size of that particular rotor pole, this is considered as a inner diameters and a outer diameter. Similar at here also. Okay, right? Here we have to consider here to here. This is the diameter, but here the considered as a single diameters. So if we want to compare these two, then we have to consider the mean diameters of the machine. It means the air gap to air gap. Are you agree with me? Here also we have to consider center to that particular shaft. This diameters we have to compare. Based on that, we can say that the axial field machine produces the good torque compared to the radial field machine. Similarly, main and importance is efficiency and the number of poles. Of course, the number of poles is important because I have already discussed and I have already put up a point that the torque ripple. And if you want to reduce the torque ripple, then what we have to do? We have to increase the number of poles. Okay, it means we have to reduce the step angle. So if we decrease the step angle and increase the number of pole, right, then automatically your torque ripple is reduced, and this one is a mandatory for electrical vehicle. Okay, and if we compare this number of poles with the efficiency, then also we can easily find out that the radial field machine and axial field machine, if we compare, the axial good the better result. Then similarly, the stator teeth. Okay, here we can easily find out the stator flux density versus the efficiency. So he can easily find out the stator teeth. If we increase the stator teeth in case of the axial flux, in case of the radial flux, so you can find out the efficiency is good. So the core flux density is increased. Look at here. If here we compare this particular things with the other aspects, then we can easily find out that if the stator teeths are increased, then core flux density is also increased, the efficiency is also increased. Then even iron losses are also little bit even iron losses are also little bit increased that because of the flux density, but the copper losses are decreased because of the length of number of turns, right? But in case of the radial flux, the copper losses are considered as the same, iron losses are increases, but phase inductance is decreases and efficiency is almost constant. Are you agree? So look at here, the entire argument is given at here. So based on that, we can easily say that based on the mathematical modeling and result, The proof the axial field method is more efficient for the SRM and PMBLDC motor than the radial field. As it's below mentions comparisons. So let me find out the comparisons of the radial flux and the axial flux. If we think for the efficiency and torque, the of course we just prove that the torque and efficiency both are good in case of the axial field. Then the high speed. So of course, easy with the good efficiency, the speed, high speed is possible for the axial field because its structure is also light. Rotor structure is lighter compared to the radial field machine. Now the losses. Losses is also less. Just we have proved the copper losses is reduced. Heat dissipations. So of course, in case of the axial field machine, what's happened that the rotor and stator cores are little bit separate, and the contact area with the environments is more. So we can easily find out. Just we go for the that particular comparison. Look at here. Here the rotor is inside, and here the rotor is mounted at like this. So here the core is directly contacted with the environment, so the air dissipation is also good in these cases. Okay. Now, yes. Now once again, now force balancing. So here the force balancing it means the equally force is created at every portion of the motor. So it is a force balancing also good. The magnetic pole shape, no arc surface, less weight. This is also the main and important things. Look at here. If we go further, once again we go to that particular scheme. Look at here. Here in air gap, here is the air gap. And in this air gap, there the uniform air gap. No arc is there. But in this case, the arcing is there. Are you agree with me? So due to that arc, the flux distribution is also create the some issues due to that particular changing in arc length. This thing is not occur in axial field machine. Of course, the many designs are available in axial field machine, but we just compare these two. The magnetic pole shape, then back iron at rotors. So here the back iron is not required, and here the back iron, it means the supporting structures that for the completing the magnetic path is required. Air gap, the no changeable, here possible to change. How? Just we changing that particular pole position, rotor stator pole. Once again we go at that. If we just move this, then we can changing that particular. Now once again, winding at stators. So it is a long end and this is a short end. The stator lamination, the circumferences, and here it is easy. Of course, it has the some advantages, but compared to the advantages, disadvantages are more. Okay, right? So axial field is nowadays hot research topic for that particular SRM and PMPLDC. And now people are also think to introduce this axial field distribution technique in an induction motor and conventional DC motor also. So the conclusion 3 is motor is a heart of EV. The one thing is clear. We have already discussed. We have also discussed about the SRM and PMBLDC and why these two motors are strong candidates for EV. Okay, right? In these two motors, if you want to change and if you want to improve the efficiency and make it more suitable for the electrical vehicle, then definitely there are the two comparisons, radial field and axial field. Of course, both are the good. Independently, I have just put up the argument that what is a radial and what is axial. Okay, right? Now you have to choose the techniques according to that particular machine and application, and you have to try to improve the efficiency of that particular motor for electrical vehicle and make it more suitable for electrical vehicle. Now, History and present. This is the most important parts. Actually, up to the last, we have concluded that the PMBLDC and SRM is good, and we have also discussed for the axial and radial, but there are lots of research are already performed, and from where you have to start, from where you have to think. So for that purpose, you must aware about that the history. So here I have just based on that particular good papers, I have concluded some papers in this particular presentation. So look, you can easily find out the literature review about that particular PMBLDC machine. So here in this PMBLDC machine, that two type of motors they have put a design and compared. One is a interior permanent magnet and the surface permanent magnet. Interior, it means the permanent magnet is a inside here, rotors inside, and surface, it means this is the rotor and the permanent magnet is projected. Okay, and they have compared the two design and identify that if we fitted the surface mounted permanent magnet machine, then it give the power factor is a little bit good and efficiency is also good, 37.1%. Look at here, if we just replace the interior permanent magnet or with the speed, then what's happened, your motor efficiency is improved, it means electrical vehicle efficiency is automatically, okay, right? Thing is already done by the some authors. Now here you can easily find out that if we increase the number of poles, up to the last discussion we have discussed with the 6 by 4 or 8 by 4 structures or 8 by 2 structures, it means the number of rotor pole are less, okay, right? Here they have you increase the number of stators and rotor pole, so because of that what's happened, the torque ripple is reduced, okay, right? And if torque ripple is reduced, then what's happened, it's more suitable for electrical vehicle. Now, if we go a little bit further, that this is the new technologies where easy to control the direction of the torque by each armature winding. In the previous design, the people have found out that direction of the torque it is very difficult. So if we find out that the only forward directions of that particular torque profile, then what we have to do, we have to just put up the permanent magnet with a particular angle and we have to mount in such a manner that it's give us the better result, right? Now the some authors has identified that if we put up a disc in place of the big rotor, then what's happening, okay, right? So they have put up a disc, it means this is a one type of, once again, that a axial field distribution. Now here we can easily identify that two multi-disc permanent magnet motors, okay, right, where this is the stators and here the two rotors multi-disc we have to put up around this particular rotor, and due to that what's happened, the two air gap is introduced and because of that the axial field distribution is possible and because of that the particular torque profile is improved. As we have discussed, the axial field techniques give the more torque compared to the radial field. Now the some people have identified that if we wound the winding at a stator side, then it is more difficult. Okay, so they have suggest the printed stator winding. So look at here, this is the stator. You can identify where you have find out some PCB design. So this is not a PCB design, this is the winding on a particular pole. This is the pole and this around they have set the winding. Okay, so this entire thing is become a one pole with the PCB winding. Okay, now we go for this is that particular rotor. So this is the flat rotor disc and this is your particular stator and rotor. So it's mounting something like this. So from this we have to provide the winding to the stators. Now the beauty of this particular design is it's possible to fit inside of the wheel, okay, right? And as we know that permanent magnet motors characteristic is exactly matched with the electrical vehicle characteristic. Okay, so it's reduce the transmission losses if we fit inside of the wheel. Now the same things here also, the author has designed a particular motors, PMBLDC, permanent magnet machine, and fit inside of this particular things. Okay, right? Then what's happening? If they fitted, then once again the transmission losses are reduced. And the look of that particular motor is something like this. This is a stator, and these two sides are a rotor, and on these rotors they have fitted a wheel. Okay, just you all are taken idea the which type of designs are available and which type of designs are already on research. Now look at here. This is the tire. We can easily identify the proposed magnetic gearing and existing planetary gear mechanism. So the people have found out that if we put up a such kind of motor inside of the wheel, okay, right, and we just remove the gear mechanism, because the gear is a mechanical things, and if we enter the mechanical gear mechanism, the losses are occur. But in place of the mechanical gear we just replace with the electrical gear mechanism, then what's happened? Okay, right? So this one is the new and advanced research topic, where this number of rotors and stators are put up in such a manners that they make a particular gear. Okay, right? It means this is the rotor. Now this is a, here we can easily identify that the motor outer rotors, then gear inner rotors, then motor stators and gear outer rotors, then stationary steel pole pixels and the permanent magnet. It means the outer side it is they have set the permanent magnet, and then after 1 2 3 and 4 rotors they have placed. Okay, so now what's happened due to this particular mechanism, the first to second, first is a rotor and second rotor it is considered as a stator. Now when the second rotor is considered as a rotor, then third is considered as a stator. Now the third is considered as a rotor, then fourth is considered as a stator. And because of that, it is moved in such a manner, okay, that it's create the gear mechanism. Are you agree with me? So this is also the new advanced research topic. It is an electrical gear mechanism. For the better understanding, the author has also put up the colorful figure where you can easily find out the stator is inside and final rotor is the outer side, and in between subordinate rotors are there, which work as a gear mechanism, which work as a gear. Okay, right. So I think so you better understand. Now we go for the some more design about the axial field technique. Look at here, multi-rotor and stator structures. Okay, right? So look at here, these are the stators and this are that particular rotor. Okay, so on the same shaft, they have put up the number of rotors and stator. Agree? Similarly at here, the single rotor, single stators, axial flux, permanent magnet machine structures. Are you agree? Where this is particular is a stator and this is considered as a rotor, where magnetic field is passing like this. Okay, so this is the axial machine. Why? Because we have already discussed that the magnetic field is a parallel with a shaft. Okay, so whenever the magnetic field distribution is a parallel with a shaft in air gap. Okay, actually the magnetic field is passing like this, but we have to consider in a air gap how the magnetic field is set up in a air gap. Okay, similarly at ether, this is a torus types of the structures. Okay, so torus types of the structures, the sandwich type, it is also known as a sandwich type permanent magnet machine, where you can easily find out here's the green colors is a winding, and this particular blue color, pink color, it is considered as your core. Okay, so this is considered as a stator core and this is the winding and this are the permanent magnet rotor. Okay, both side of the permanent, so magnetic field is set up like this, magnetic field is set up like this. Okay, it's entering from this, leaving from this, so here we set n s n s n s. Okay, now the same structures is something like this. you can easily find out the magnetic field distribution. Okay, it's maybe the little bit difficult to understand, but you just go through it, then you can easily understand. It is not difficult, but you just find out the idea. My motive is to find out the idea. Now axial flux, once again, torus. Look at here, the same structures, but here the projected windings they have provided. Okay, right? The similar structures we can easily find out at here. Okay, look at here's the difference between this and this. Only the difference in a stator. Rotor is remain same, but the structure of stator is changed. So what's happened? The size of that particular stator is reduced. Okay, right? And the winding space is increased. So because of that's what's happened, you know that in electrical vehicle we need more torque, and for more torque we need a more power density, and for more power density we required two things measured. First one is the current, or it's maybe a number of turns. Okay, number of, it means the n into the I. So if we are not able to increase the current, then we have to increase the number of turns, and if we possible to increase the number of turns, then we just limited that current, right? The similarly, if we increase this particular unit in a numbers on a same shaft like this, the multi-stage, then also what's happened, the torque is improved with a smaller axial length. This is the beauty of the axial field machine. This all are axial field techniques. Okay, right? Similarly, both axial and radial field techniques, which we already find out that it gives the 178 percentage more output. So if we conclude that different type of permanent magnet BLDC machine, that surface mounted permanent magnet, inner mounted permanent magnet, then with the different number of stator pole and different number of rotor pole, disc drive in wheel motors, then unidirectional current flow with the changing in rotor pole angles we have identified, then the multi-rotor design we have identified, multi-rotor design with a magnetic gear we have identified. Okay, right? Now the axial field techniques they have introduced, and based on that axial field techniques they have once again introduced the multi-disc and magnetic gear with the axial field they have introduced, and PCB type rotor and stators they have introduced. Are you agree with me? So this is the permanent magnet BLDC machine. Now we think for the SRM. So look at here, whatever the design we have identified in the permanent magnet brushless DC machine, the similar type of designs are available in SRM also. Okay, the switch reluctance motor. So in switch reluctance motor, the permanent magnet is not used. Agree? Now here the permanent magnet is not used because of that it is a reluctance motor. It means whenever we excite the particular phase, the rotor is try to align with that particular phase and minimize the reluctance. Okay, so this is the switch reluctance motor because it's try to obtain the minimum reluctance path. Okay, so this is the very conventional design where rotor is inner side and stator is outer side. But whenever you use this motor for a electrical vehicle purpose, the problem is we cannot use for in wheel. So for that purpose, the researcher has just shifted the position. This particular stator is shifted at inner side. Okay, right? And that particular rotor is put up at outer side. You can easily identify rotor at outer side and stator at inner side. Are you agree with me? Everything is remain same. The beauty of this design is now it's possible to fit inside of that electrical vehicle and in a in wheel. Now look at here. This is the radial field techniques when number of poles are increased, stator and rotor. So what's happened? Because of this, that torque ripple is reduced. As well as they have found in a previous case, we have identified that the magnetic field is designed in this manner. Look at here, my cursor. The magnetic field is designed set up in this manner. Okay, and half magnetic field is set up in this manner. Okay, right? But in this case, what's happened? The magnetic field is set up in this manner. So what's happened? The length of the magnetic field is reduced. So the offered reluctance is also reduced. Okay, right? So of course the losses are also reduced. Ion losses are reduced. Okay, so this is the beauty of this design. We can easily identify how the number of phases are excited. So here we can identify first phase, then second phase, third phase, fourth phase, like this. And because of that, it's give us the really good torque profile. Now, the every machine, this is the very important paper produced by the Raghavan sir. In this paper, that every type of machine we cannot design randomly. We have to make some model, and especially for a mathematical model. Now the question is how to prepare this preliminary mathematical model based on our thoughts. So for that purpose, here the equivalent circuit, the entire model is divided into the two parts. SRM is divided. This is the completely aligned condition where rotor pole it is in exit of the stator pole. Okay, so this is the completely aligned position. Okay, right? So the two possibilities are that one is a completely aligned position. So this is the equivalent circuit of the completely aligned position. And now second one is completely unaligned position. Look at here. Here the poles are not in align. Here the poles are unaligned. Okay, where the rotor poles are not exactly in front of that stator pole, right? So the equivalent circuit is like that. And whatever the resultant between the aligned and unaligned, it's the responsibility of torque. Okay, so from this we can easily calculate the functional characteristic of particular motor. Now this is a multi-gear. You can easily find out the number of rotors and stators are available at here. Okay, the stator at outer side and that inner side rotor, middle rotors, and this is the inner side rotor. Okay, so 1, 2, 3, 4, and 5 stages are there. Are you agree with me? And we provide the wire supply at a stator only, right? So this is something like this. You can easily identify that the shaft, then rotor structures, okay, right? And this is your stator where we have to provide the winding. This is the winding, okay? So add gap 1, 2, 3, where add gaps you have considered. So this middle one, it is working as a gear mechanism. The complete field distribution is something like this. You can easily identify the field distribution where 1, 2, and 3 stages are there. Okay. Now, the author has already tilted. Look, here just they have tilted. Okay. Now, what's happened? If we just tilted the pole, conventional pole is like this straight way, and if we tilted with a some degree, 25-degree, then also it's give the good result. You can easily find out. This is the conventional motor where exactly the poles are like this. No tilting points are there. But now if we tilted like this 25-degree, then also it's give the good result. Look at here. So this is the strategy of design. If you're changing a very small part, very small dimension, okay, or very small parameters, if you change, then automatically it's maybe give you the good result. Okay, of course these all are possible to calculate by using of that two stages mathematical modeling and by help of some simulation or simulator. Similarly, these are the two design. One is a conventional one and this is a pie chart method. Okay, so this is a conventional design and this is a pie method. If we compare these two, conventional and pie, then you can easily find identify that we have just changing and we have just changed the design of that particular code. Then what's happened? Your torque is a particular torque ripple is reduced. Here torque ripple is 110 and here torque ripple is 65 and torque is increased 130 newton meter. Okay, so plus 23 percentage is good result in pie chart. Similarly, axial field and radial field, which we already discussed. Okay, right? Now this is the new technology in field of the radial. There are the two current design, one is a tooth type and segmented type. This one is a segmented type, and this is a toothed type. Okay, right? So basically in this two design, both are axial field design, but you can easily, if we compare the tooth and segmented, then you can easily find out in segmented it's give the more efficiency, 87.5 percentage, due to reducing the iron loss. Look at here, the copper loss changes are not too much more, but in iron losses the changes are more because the air gap length is reduced. Are you agree with me? So this is the most and important part, how the flux is set up. How the flux is set up. If you just changing the flux path length, then it's directly effect on the performance of motor. So once again, we can conclude the study based on the types of the different NS and NR. Now, direct driving in wheel motors, of course, direct driving, it means by the in-wheel fitting. Designing technique by the equivalent circuit. By equivalent circuit, we can design the any type of the SRM, the pi core structures and tilted pole structures we have identified. Just changing the angle, we can get the better result. Then multi-rotor disc, then multi-rotor with magnetic gear, axial field techniques, comparison of tooth and segmented, multi-disc with axial field, multi-disc and magnetic gear with axial flux. Now at last we just compare. Actually I have give you the two machines as a result, SRM and PMBLDC. Okay, right? Now once we compare, I just provide you the comparison. Now you have to conclude these things, that this is the particular SRM and this is a PMBLDC machine. I have just do the simulations with the same dimension. Look at here. Particular basic dimensions are considered same. Outer diameter, inner diameters, and everything. Number of poles and everything. Okay, right? And based on this, what we have do? Based on this, we have identified that BLDC machine and SRM machine. The SRM has 35% lower efficiency than the BLDC machine. Of course, SRM is offered 35% lower efficiency than BLDC. It means it is a disadvantages of SRM and advantages of BLDC. But the much lower cost. It is most IAP, but much lower cost. And total weight is also low. Okay, the cost of permanent magnet, and the main and important problem is this, the cost of permanent magnet, it is a $60 per kg in US and everywhere. And there are the monopolies in permanent magnet with some countries like a China. Okay, so the people are just replace that permanent magnet machine with the non-permanent magnet machine. Of course, the induction machine is a good one, but we have already discussed it has the limitations of that speed torque characteristic as well as the limitation of that power density. Okay, right? So because of that, SRM is a good one for the betterment of electrical vehicle as per these results. So we can say that SRM is a strong candidate for electrical vehicle, and axial field technique is also the good if we introduce in the any type of the existing machine. And for the better comparison, we need some software help. So whenever you go for the preliminary design, you're free to choose the any software tool. You just implement your design, you find out the answers, okay, and then go for the mathematical model for the better justification. So conclusion is ultimately the future is EV, of course. And as per this presentation, SRM and PMBLDC, it is also the future. We cannot say that SRM only or PMBLDC. Of course, the permanent magnet is a limitation. We can also say that the axial and radial, both are the future. Radial is a conventional one and axial one is a new technology. Okay, right? And we think for the EV, then we must go for in-wheel technology for reduce the gear losses. Okay, right? Or we have to introduce the electrical gear mechanism. And base this is the conclusion as per the my words and my presentation. Now you have to conclude and you have to go further for the betterment of the vehicle. Thank you very much. These are the references. Thank you. I hope my entire presentation is really fruitful for you. Thank you. Thank you very much.
Okay, thank you, sir. Thank you so much for sharing this type of the content to the participants. Now, sir, two questions are there in the chat box.
Yes. Yes.
Yes. What about the maintenance of electrical vehicle? Is it economical compared to non-renewable fuel vehicle like petrol and diesel?
Okay. The question is really good about the maintenance.
Yes, sir.
So our main aim of this presentation is to that advancement of electrical vehicle, and I have also put up the one PPT challenges. Okay, right? So this is the big challenge that people are not too much aware. Of course, the technology is not completely matured, but it is mature up to the certain level that we can accept the electrical vehicle. Of course, the price is a matter. Okay, right? So if we think for the electrical vehicle, the battery part is a main and important aspect for the regular maintenance. But it's nowadays the lithium ion batteries and other batteries are invented in such a manner that maintenance cost is reduced and reduced. So of course, whatever the new designs that comes in the market, they all are less maintenance compared to the internal combustion.
Yes, sir. One another more question. Can electrical cars overheated?
Yes, this is the good questions and purely technical. Actually, I appreciate this question. Electrical cars are overheated. I have number of time used the one word power density. Okay, right. So if we use the induction motor, right, then the some limitations are there. We cannot feed the more current. Otherwise, my motor is maybe burnt. Agree if we think for the motor point of view. But if we go for that particular SRM or PMBLDC, then the winding is wound in such a manner that we go for that particular over power density. Okay, right? So it's purely based on the cooling system, and according to the my knowledge, that in electrical vehicle is not heated as we think. Okay, so there is a no heating problems occurs in that particular electrical motors which I have visited the current design of the data.
Yes, sir. One more question is there, sir. Do electrical car lose charge when it is parked?
Yes, please.
Do electric cars lose charging when it is parked?
Where it is okay, there are the
Yes.
two possibility actually in fast charging and slow charging. Okay, right? If you go for the slow charging and your charging station or charging point is sufficient to carrying that load, then there is a no possibility of charging. Of course, at a initially whenever you on the switch, okay, it also the spark. The similarly here when you start to charge any batteries at the beginning, it's take a high current, and because of that it's maybe the initially your contact is loose, and because of that it's possibility of charging. Otherwise it's not a possibility of charging during and starting at the charge.
Okay. One more, sir. What about battery charging and changing mechanism future?
Okay, battery charging and changing, there are the two possibilities, that the battery charge or a battery replace. Okay, the two type of stations maybe comes in a nearest futures, but charging is take a more time compared to the changing. Okay, but changing it is little bit mechanical structures. We have to just replace the complete battery rack with the existing rack. Okay, so both are feasible, but it depends on the how many numbers of vehicles apply on road. Okay, if the numbers are increased, then definitely facilities are day by day increase. Okay, so it's purely game of the how many people response come for the electrical vehicle.
Yes, sir. Okay, sir. Thank you so much for giving the such kind of the answering. Okay. So now we will stop our session, and next session we will start 1:30 o'clock. Thank you so much. Thank you, sir.
Okay, thank you very much.